So what we tried to do was this, right? So in this, we need to find out the value of capital Fu, which is the cumulative distribution function. We need to integrate it between minus infinity to infinity. And because the PDF exists between 0 and 1, we need to write the limits 0 and 1 in place of minus infinity and infinity. And you need to again solve this by writing that whatever is there in FUU, and then you will get this. Substitute the upper limit first, and then the lower limit then next. Okay, upper limit if you substitute, you'll get exponential of the minus half. Lower limit if you substitute, you'll get exponential of 0. So what you call, you have here the what you call this minus 1 by 2 will become minus 2 here, and this whole thing will be there, which is exponential of minus half is minus 60653. And you can solve this quantity is minus and minus will cancel, and you'll get something over there, and that is 1 by 0.787. That will give 1.2707. So first we need to find the value of C, and then having found the value of C, then we need to find FU 0.5, that is the limit there. So 0 to 0.5. So in place of 1, this becomes 0.5, and then again you integrate this whole thing, and you will get this as 0.65622, right? Similarly, you need to find the 18 also in the same way, right? Here it is minus u by 2. This is again same thing, except that here it is minus u by 3, that's all. Here it is minus u by 4. So both this will become the exercise for the, what you call assignment. So try to solve this, that will help you only in the long run, right? Then we'll go for the next problem. So here 20, 21, and might be 22 are given. So this is very straightforward, because we have solved here a very big example. You need to solve it as a very small example, right? So for this, given the data in the following table, plot the PDF and the CDF of the discrete random variable y. Okay, so you can plot this value is capital P of yk. So capital P of yk is the value which is written over here, right? So this total value will turn out to be 1, right? So we can try to find out that value, total value. You just add this up, all that I hope will become 1, because 4 plus 9 plus 1 plus 6, so that will be 2. 2 plus 2, 4, 5, 6, 7, 8, 9, 10. So that total probability will turn out to be 1. So the probability density function will be just the values which this takes, right? So similar to the plot for the probability density function going up and down or whatever it is. Then the CDF will be continuously increasing, because CDF will just correspond to, in the first case, this will be 0.2. Then you need to add this 2 and write it over here. Then you need to add all the 3 and write it here. Then you need to add all the 4 and write it here. And then you need to add all the 5 and write it here. Okay. So this is the PDF. The CDF will be, you need to write this straight away in the first case. In the second case, both these you write and add it over here, and then so on. Okay. You can try to write it that way. What is the purpose of yk? Okay, write expressions for fyy and okay, PDF and CDF for y is what he is asking, but what we try to write is the probability PDF for the variable x, right? So for y, you need to use the corresponding formula there, right? So the formulas which we might have written corresponding to y are here. How's the y and x related? Okay, y and x, the y and x are, y and x are related in some way. So we need to use that and try to find out, right? Just find out that y for this is for yk itself. This is for yk itself, no problem. You can find it straight away. Write expressions for fyy and fyy using the unit delta functions and the unit step functions. So you can try to write this and solve. Similarly here, given the data in the table corresponding to this, you can try to write the PDF and the CDF for the variable x. Okay, this is for the variable y. This is for the variable x. And again, write expressions for fxx and this is PDF and this is CDF. Okay, that again becomes the exercise. Any doubt in this? You can see here, this is written straight away here. These two are added and it's written here. These three are added and it's written here. These four are added and written here. These five are added and written here, and so on. So if you add all these, you'll get one, right? So that's how it is. So same way we need to do that. Only that these values will be at xk, what is the value of pk? Okay. At 2.1, you have 0.21. At 3.2, you have 0.18. So the plot of that will be, something like this. It will be like this. So you will have to write this. At what value, what is the function? Then it will be this type. The CDF will be this type. PDF will be of this type, but only at different values. Might be here you have x equal to 0, 1, 2, 3, but there you might not have 0, 1, 2, 3. That's all. It will be at some other values, normal values, which might be, yk equal to 2.1, 3.2, and all those things. Any doubts till now? So unless you don't study, then doubts will not come. So it is for you to study that and then find out where you have not followed. So again, next class, leaving these problems, right? If you have any doubts till this, fine. If you are able to solve this, it is fine. Once you solve this, then the next thing what you need to do is you need to check the next problems, right? You need to check the next problems. So till 21 it is all right. 22, 23, 24 till might be 6 or 9 problems you try to solve on your own and see whether you have followed or not. And if you have not followed, you should ask. As simple as that, right? So you have the problems over here, and I think I might have put the chapter 2 also in this PDF also in the classroom, Google Classroom, and you can just go through that. Any problem which you are not able to get, you should be able to ask. Okay. So we will stop at this for today. Again, please study and come. So shall we have the class in the morning, 9:30 tomorrow? somewhere around 9:30 to 11 will be 2 sessions which we can finish it off. If people are is this time all right? It is for you to tell me. If this time is all right, fine for me. Otherwise, 9:30 to 11 also will be all right for me. Whichever is convenient, you can tell. Yes, you're able to hear me? I'm asking you about the time. Is this time 5:30 to, whatever, convenient to you, or shall we take from 9:30 to, around 11? Morning is better, or this time is better? Yes means which yes? Morning is better. Okay, we'll have 9:30 to 10, but I should feel that, the attendance should be more than this. Otherwise, I'll shift back to the evening. There's no point, people coming, 11 people in the evening and 11 people in the morning. There should be good attendance. Tell everybody that they should attend. It is for their, sake. And if they have doubts, they can ask. Okay. So we'll call it a day for the present, right?